It all started with the invention of the transistor. A transistor is a semiconductor device which can amplify or switch electrical signals. Today, I can talk with a person sitting in some different part of the world, or I can order food, or book a cab, all using my mobile phone. The invention of semiconductor technology, particularly the invention of MOSFET transistor, is considered to be the most important invention in human history, which propelled human civilization from industrial times to today's modern digital era of social media, YouTube, WhatsApp, and so on. The inherent physical property of switching electrical signals is a very important idea, and going forward, we will understand why. Hi, I welcome you all to this next video. I don't know how to start. This is my first video, or I should say, this is my first appearance in front of a camera. In this lecture series, we will learn all about Spring Web Framework. For those of you who don't know what is a lecture series is kind of a playlist. When I talk about a topic, it's very difficult to put all the content into a single video. I have seen some videos on YouTube which are of 3 hour or 4 hour in length. Like, I don't know how people can watch that much long video. It's better to break down the content into multiple smaller videos. Before I even talk about Spring Web Framework, I want to talk about computers in general. It's very important for all of us to understand computer fundamentals. The journey from industrial world to today's modern digital world is a very interesting one, with several milestones and inventions along the way. To start with, let us find out the answer to the most fundamental question we all must have. What is a computer? So this video will be all about answering this question in as simple language as possible. If you haven't already, please subscribe to the channel, like the video, and share the content as much as possible. Before I explain what is computer, do you know that computer does have an abbreviation? Computer stands for Common Operating Machine, purposely used for technological and educational research. To put it in simple words, it is a machine developed by us humans to perform certain tasks better than us humans. We all, in some kind of a way, interact with a computer on a daily basis. Smartphones, tablet devices, or smart televisions are all intelligent machines built by us humans and in some form a kind of a computer. Why is there a need for computers? Initially, computers were designed purely with the purpose of doing certain tasks much faster than humans. For example, doing mathematical calculations or performing arithmetics or keeping record counts and so on. Later on, the invention of semiconductor technology and general purpose programmable computing model has allowed us to achieve such greater tasks as booking a cab online. Computer is a machine, and like the two sides of any coin, computers also have two distinct aspects associated with it. First one is the hardware or the physical aspect of the computer. Second one is the software or the logical aspect of the computer. For the rest of this video, let us understand the hardware aspect of the computer and various milestones and inventions along the journey. Machines have been used by humans as an aid to perform tasks for thousands of years. We humans have been using ABACUS since at least 5000 years to aid in arithmetic computations. These earlier devices have direct one-to-one representation with the fingers or digits. As time progressed, we have developed more advanced, sophisticated machines to accomplish complex tasks which were not possible by humans. The Antikythera mechanism was an ancient mechanical device that can predict the motion of celestial bodies like the sun or moon, and it is used to predict solar eclipses in advance. It was also used to track the 4-year cycle of ancient Olympic Games. To model the motion of celestial bodies, the Antikythera device has corresponding dials made up of bronze which rotate in such a fashion as to mimic the physical motion of the sun. The earliest known use of Antikythera mechanism device was around 100 BC, and devices with such similar complexity did not appear again until the late 14th century AD. The next major evolution in the advancement of computers came with the invention of electricity. The invention of electricity is crucial because then we can design electrical circuits as a physical model of logical implementation. To understand this, let us consider an analogy. The voltage across a junction in an electrical circuit is defined by the Ohm's law. It states that voltage is equal to current multiplied by resistance. So using an electrical circuit, we can simulate the logic of multiplication or division of two numbers. By measuring the voltage or current in an electrical circuit, we can measure the result of the arithmetic operation. With the invention of electricity, earlier historic devices like the Antikythera device were soon replaced by more modern analog computers. Analog computers use the continuous variation aspect of physical phenomena such as electrical, mechanical, or hydraulic quantities, also known as analog signals, to model the problem being solved. The analog signals are continuous in nature in comparison to the digital signatures that have fixed states on or off. By the late 1930s, the art of mechanical analog computing reached its zenith with the launch of differential analyzer. The differential analyzer is a mechanical device used to solve differential equations by integration. Earlier computers were huge in size, had special power and infrastructure requirements, and were designed and built for specific purposes like number 1. Calculating the differential of mathematical equations. Number 2. Predicting tides. Number 3. As aircraft control systems. Number 4. Flight simulators. Number 5. For research and military purposes. During the start of the video, I mentioned that switching electrical signals is a very important idea. Let us understand in detail what it is and why it is important. Before the invention of transistors, there was no general purpose mechanism to represent logical structures onto computers. For example, if I have to represent this arithmetic equation or characters, numbers, symbols, anything, Boolean algebra, it was not possible to do it before the invention of transistors. With the invention of transistors, the mechanical and electromechanical parts of a computer were soon replaced with their equivalent digital electronic circuits. Transistors played an important role in this transition from mechanical to digital circuits. Let us understand how. Transistors are made up of semiconductor material like silicon. A technique called doping is used to increase the conductive properties of the semiconductor material. P or positive type doping is when silicon is doped with boron, and N or negative type doping is when it is doped with phosphorus. A transistor consists of three semiconducting layers where a p-type doping layer is merged between two n-type doping layers, or vice versa. It creates two diodes as shown. A transistor has three terminals. One is known as source, another one is drain, and the third one is known as gate. If we connect a transistor to an external circuit, we see that no electric flow is possible. It is because the electrons cannot cross the barrier created by depletion layers in the diodes. This is known as the off state or low state of the transistor. If an external voltage is applied to the gate terminal, it creates a channel for electrons to pass through and electric flow is possible. This is known as the on state of the transistor. Think of the gate terminal as the control terminal or input terminal, whereby if a voltage is applied to it, the electric current flows through the circuit. There are multiple types of transistors. The most prominent among them are field effect transistors. Here I presented you with a very simple explanation of the transistor. In reality, there are some more technicalities involved with how a transistor functions. I will attach some videos in the description section for you to go through if you are interested in this topic. For the purpose of this course, or for the purpose of understanding computers, this simple conceptual understanding should suffice. A transistor can have two states, on or off. However, we can combine multiple transistors to have more possible states. The number of possible states can be represented as the power of 2, and this is known as the binary system representation. A transistor is a direct physical implementation of the binary system. Now here comes the most interesting part. We can combine transistors in any particular order to form logic gates. Logic gates can be cascaded, meaning the output of one can be connected to the input of other and so on, allowing for a construction of such circuits as adders, subtractors, multiplexers, resistors, arithmetic logic units, computer memory, etc. all the way up through microprocessors, which may contain more than 100 million logic gates. Logic circuits allowed the construction of a physical model of Boolean logic, and therefore all of the algorithms and mathematics that can be described with Boolean logic. Transistors were perfect for logical implementation, but initial bipolar junction transistors had one physical limitation. They were bulkier in size, about half an inch high, and combining them for mass production was not at all practically feasible. The metal oxide semiconductor field effect transistor, or MOS transistor, was invented by researchers at the Bell Labs in 1959. MOSFET was the first truly compact transistor that could be miniaturized and mass-produced for a wide range of uses. The MOSFET transistor is the most widely used transistor in the world and is one of the greatest inventions of human civilization. As technology improved, the number of transistors that could fit on a microchip has increased at an exponential rate, resulting in an increase in the computing power by a trillion-fold in the past 50 years. If we plot a graph, we see that number of transistors on a microchip doubles every 2 years. This is known as Moore's law. It is named after Gordon Moore, the founder of Intel. Mr. Moore predicted in 1965 that this doubling of transistors would continue for at least next decade until 1975, but it's fascinating to know that it is still going on after 50 years. You see, Moore's law is not an actual physical law. It is merely an observation and projection of a historical trend. Not just for microprocessors, transistors are a fundamental component for computer memory as well. The most common form of memory, dynamic random access memory, is a combination of a transistor and a capacitor to create a memory cell, which represents a single bit of data. The capacitor holds the bit of information, a 0 or a 1. The transistor acts as a switch that lets the control circuitry on the memory chip read the capacitor or change its state. Similar to a microprocessor, a memory is an integrated circuit made up of billions of transistors and capacitors. In the 1980s, as computing power was increasing, it was getting cheaper as well, and with the advent of single-chip microprocessors, the dawn of personal computers began. Apple was founded in April 1976 by the late legendary Steve Jobs, who revolutionized the personal computer industry.
On January 24th, Apple Computer will introduce Macintosh. And you'll see why 1984 won't be like 1984.
The first Macintosh computer was released in 1984, and we have come a long way since then. That's it for today's video. I hope you have liked the video. If you do, click on that like button to show your love and make YouTube algorithm happy. Let us have a target of 100 likes. ज़्यादा तो नहीं है, शायद नहीं, इतना तो बनता है. Your support is the only motivation for me to continue to make these videos. Thank you and keep learning. I will see you in the next one.